Hello guys, welcome to the YouTube video, and in today's video we'll be looking at some good old recursion. So let's start off. So what exactly is recursion? Recursion is a technique that is used when functions call themselves over and over again. So recursion has two parts. There's the base case, which is the answer to the smallest subproblem, and the recursive step. Let's go into an example. So let's say we want to add the sum of the numbers from 1 to 7. Maybe change this, or let's just do from 1 to 4. Okay, to do this we can do two things. The iterative way to do this would just be add 1 to 2 to 3 to 4. But if we want to do this recursively, we know that the sum of all the numbers from 1 to 4 is 4 plus all of this, which is the sum of the numbers all the way to 3. Okay, so this will be shown as a 1, 2, 3. We know the sum of all these numbers from 1 to 3 is just 3 plus the sum of all the numbers till 2. So sum 2. We know sum 2 is 2 plus the sum of all the numbers to 1. Now, we may be asking, now we got to 1. What do we do? Well, we've arrived at what we now call the base case. So the base case here is the smallest. We can break this problem down into the sum of 1. And we obviously know that the sum of 1 is just 1. So once we get to this stage, we can just add 1 plus 2. So we know the sum of 1 plus 2. We know this is 1. 1 plus 2 is 3. So we know the sum of 2 is equal to 3. We know 3 plus 3 here equal to 6. So the sum of 3 is up the way to 3 is 6. 6 plus 4, 10. So we know the sum of all the numbers from 1 to 4 is equal to 10. So that is how recursion can be used. So in this example, the base case we have, the smallest subproblem was the sum of 1. The sum of 1 here, which the sum of 1 is just equal to 1. And here, the recursive step is that we just take the number itself that we put in the function, whatever the number might be, we just call it n. For example, we just take n, the number, and we add it the sum of 1 lower than it, so n minus 1. So here we take 4, which is n, and we add the sum all the way to 3. Then we keep doing this over and over till we get to the base case, and then the recursion is solved. So let's go down to the computer here and let's take a look at this in code. So first, let's start off. So we'll name the function sum here. So we take in the value, specific value here, which is the number we want to go up to the sum of. And then, so we start off, we know, let's start off with the base case. So we know if the value is 1, then we know the sum of up to that value would just be 1. Else, we go into the recursive step here, which is we take the value itself and then we add it to the sum of value minus 1, just like how we showed on this previous writing pad there. So yeah, this is a simple recursive function, and yeah, let's see how it works out. So if I just type in the sum of all the numbers from 4, this should return 10. 10. Good. Let's try 5. This should be 15. Then this should be 21. So now we're gonna go back to our writing pad and see look at one more example. Okay, so let's look at iteration versus recursion, which are two different looping mechanisms in programming. So first problem we have here, Stack Overflow. Okay, so let's go back to the sum example and show an example of how Stack Overflow can occur. So let's say we want to take the sum of the numbers to 3. From 1 to 3 here. All the numbers from 1 to 3. We start off with 3 plus all the numbers, so 2. Now we need to figure out what the sum of the numbers from 2 is. That is 2 plus sum of the numbers from 1. Now we need to figure out what the sum of 1 is, which is the base step here, which is just 1. So as you see here, this is just a very small example, but as n becomes bigger and bigger and bigger, the function calls we have just keep stacking onto each other over and over and over again. They can't resolve because the final one has to resolve here. The base call has to resolve before we go down and start resolving this. So off with 1, 2 plus 1, that's 3. So we put 3 in here. 3 plus 3, 6. So as you see, as we add more and more calls onto the recursive stack, you can easily overflow, which is one of the problems with recursion. Another problem is the infinite loops you can get. For example, if you have the sum and you forget to put a base step, you're just gonna keep going. So let's write out the sum here. If you forget to put the base step, which is the sum of 1, or is equal to 1, then this just keeps going down and down and over and over and over again. So for example, if we have 3 here, we have 3 plus the sum of 3, 3 plus sum of 2, 2 here is 2 plus sum of 1. Now instead of stopping here, we just keep going. Sum of 1, 1 plus sum of 0, sum of 0, 0 plus sum of minus 1. So I can see this can just go infinite many times and crash your program. Let's look at another way that iteration can be superior to recursion here. So let's go back to the sum example. If we want to take the sum of all the numbers to, let's say, 5, we've already seen the recursive version. But a way to do this, which is not even really iterative, is just a way to do it with math. Let me draw this out. It's a geometric way to view the sum. Okay. So the sum of all the numbers from 1 to 5. So we see here, this is 5, 4, 3, 2, and 1 squares respectively. So we want to add up all these squares. Well, if you notice one little thing here, is that if you duplicate the structure I have at the bottom, flip it over and place it on top, you can see here it forms a perfect rectangle. And how do we find the area of a rectangle? We just take the height times length. The rectangle here. So what's the height of this? 1, 2, 3, 4, 5, 6. The length 1, 2, 3, 4, 5. So we're just gonna have 6 times 5. So that will give us the area of this entire cube. Now we obviously know that we just duplicated the cube and placed it over to form this rectangle. So we know that we just have to divide it by 2. This number we got here by 2. So we divide 30 by 2 and we get 15, which is equal to how many squares we have here. So we have 15 squares total, and the sum of all the numbers from 1 to 5 is 15. So you see, this way we didn't have to stack stuff onto the stack or keep going the method over and over. We could just simply use math and quickly solve this sum problem. So this is an example where going down the recursive path might not be the best decision to make. And this can also work for any number. We just call the number n. So if we want to know the sum any number from n, we can just take n times the n plus 1, as we saw, because the height's going to be 1 higher than the length. We get the square and then we divide it by 2. So that is one way to find the sum of a number very fast. So thank you guys for watching this video, and have fun learning recursion.